intercepts and symmetry of the graph. And this is the graph of the cosinverse,
Yeah.
right?
I just didn't know how to state how it was symmetrical.
So y equals cos inverse. That graph, so let's talk about the domain and range, because for me that's, I know that you had to plot points and all
Yeah,
that kind of
yeah,
stuff. But what is the domain of the cosinverse?
That's all the
Cos
cos
inverse.
inverse.
No, negative
Gosh, these
1
are
to
all
1.
confusing my head.
Negative 1 to 1. And what is the range?
0 to pi.
0 to pi. Okay, so I know, so I'm going to go, the range, here's pi over 2, and here's pi. Here's negative 1 to 1. Now, here's what I like to do. The regular cos graph goes like this, and that would be pi over 2. So this is the point 0, 1, and this is the point pi 1, negative 1, excuse me. So now it'd be negative 1 pi, pi over 2, 0, and 1. So it's going to look something like that. Okay? Did your graph look like that?
Yeah.
Groovy. Okay.
Mine just was really stretched out. But
So now, it wanted to know.
It just wants to know how it's symmetrical because I got the intercepts.
So is there any line symmetry? Like line symmetry would be, ooh, it flips over that line and it looks exactly the same on the other side of the line as it does on this one.
Yeah.
Well, yeah, but it's
This one,
yeah.
this one itself. Which line? So if you flip it across this line, this is what it looks like.
But it's turned. It's rotated.
Okay, so it has rotational symmetry about the point
0 pi
0 pi
over 2.
over 2.
Ooh.
So there's rotational symmetry about the point 0 pi over 2. Okay, because we can take that and turn it, and it ends up on itself. Okay?
Okay. That was my only question.
Okay, that was the only question. Awesome.
oh, actually, I have one.
Okay, good.
I'm sorry. For the tangent, the inverse of tangent graph is 3. It was like asking for an asymptote. So, and then when I graphed it, there wasn't any vertical asymptotes, but is there a horizontal asymptote?
Yeah, and that's
Okay.
actually part D said determine the horizontal asymptotes of the graph.
Okay.
So yes, there would be some horizontal asymptotes, and what would those be?
Would it be at 1.5? Because it never actually reaches it. It gets really close, but it never actually
Is
gets
it 1.5?
Yeah.
Yeah.
Equals tan inverse of x. So I'm going to say I don't think that the horizontal asymptotes are 1.5 and negative 1.5. And plus, if I was giving a horizontal asymptote, I would write an equation of a line and not just give it 2 numbers. Okay? So now, the tangent curve itself, let's go back over here, move this. So if I was doing the tangent curve, it would look like this, right? Whoops, it would look like this. Close enough. Okay. And it would have asymptotes here and here. Correct? What is this value right here? Negative pi over 2. And what is this value? Pi over 2. Now when I go to graph the inverse of this guy,
See, it gets real close to 0.6.
then this is this asymptote right here is y equals pi over 2. And this one, x equals Sally. And this one is x equals negative pi over 2. Those are our vertical asymptotes. So now I flip that thing over, and I get asymptotes here, and here, and,
Actually, it's 1.5.
dang it, let's go,
Because is that pi divided by 2? Oh, because pi divided by 2 is 1.5.
Okay.
Yeah.
all right, now, is it just, do I just say, oh, the asymptotes are pi divided by 2 and negative pi divided by 2? It's y, so this line has an equation of y equals pi over 2, and this one has an equation of y equals negative pi over 2. So do you guys see what I'm saying?
Yeah.
Okay, so even though on your calculator you were getting decimals,
Yeah.
you really got to remember what the domain and range of that thing is, of this thing.
I
Okay?
didn't even think about like why, because I swing so often.
That's because they were asking you to plot points, probably.
Yeah,
That-
and like, they never gave you anything close to pi. They gave you something like 4/7, so then I was like, oh, it's not gonna go. Like they have you graph it at like negative.
As you can imagine, the value of inverse trig functions is much greater than just using it for composition functions. You can use the inverse trig function, you can use those to solve trig equations. And this is where the fun begins. You thought it was fun before? Now wait till you get this. Today is the 10th, and what we're going to do is we're going to use inverse trig functions to solve trig equations. I want to know, so if I asked you to use your calculator to do this, why don't you do this? Why don't you find the x value that makes this equation true by using your calculator? And
So would you graph it?
No, you do the inverse cosine of 1/2.
okay, yeah, okay, so there's some question, right? How do we do it? You guys could actually solve this by drawing a triangle, right? This is asking for the cosine of what angle is 1/2, right? Well, we have an operation actually now that would help us do that. So to solve this equation, we could take the cos inverse of both sides of this equation. So we can do cos inverse
Oh, it's pi.
of cosine of x equals cos inverse of 1/2. Now you could use your calculator, boom, boom, to get the value of x.
Okay.
And did you do it, Johanna? What'd you get? 1.047.
Go with pi over 3.
Okay, so we could we could actually use the unit circle to get this too. You guys should recognize, what would this is an approximation by using your calculator. That some calculators will give it to you in radians, and this is radians, by the way. Some calculators will give it to you using the pi. What would this be? It should be pi over 3 or 60 degrees.
Do you want it in radians?
Right now, I don't really care. We've been doing them in radians for this cos inverse. So, but if you said x is 60 degrees, since I didn't say, that would also be fine. Okay. So this is the approximation. This is exact, and this is exact. So if you were using your calculator to get it, that's all you would get. But now let's take a look at what it's asking. So if we look at the graph, oops, that's just a bad vertical line. Okay, okay. If we do the graph of y equals cosine of x, This is just a little sketch. Okay. Well, a half is right here, ish. I don't know, about right there. So that's pi over 3, right? But is that the only value that makes this equation true?
Oh, it could be.
It could be negative pi over 3 also makes this true. Oh, look, there's a half. And here's one over here, and here's one over here, and here's one over here. So if I drew a horizontal line of y equals a half, how many solutions does this actually have? It has an infinite number of solutions. So we have to be careful when we're solving equations and answer the question that they're really asking. Well, yes, this is one value that makes this equation true, but there's an infinite number of values that make this equation true. Jackson Morgan.
Didn't we limit the domain of the inverse cosine to?
We did, but that's not asking this. This is asking the cosine of what angle, or angles, is a half. So this is not, I didn't start out with cos inverse on this. I didn't start out like this. If I had started out like this, there would only be one. But I started out like this. So when we're solving trig equations, we have to look at it and we have to say, oh, is it just that one? Or could there be more? Okay, and so you have to kind of look at the entire thing. Okay, so you can use your cos inverse to kind of give you a starting point, but it doesn't mean that that's the only one. Okay, so good question there, Jackson Morgan. So let's see.